Okay, I'm here to present Quinn, Nate's, and Joe's Lab 2 Part A. I currently have this set up so I can show you the inner workings of the actual sequential circuit that was designed, and then I will pause it real quick and then switch it so I can show you the overall circuit. And then after that, I'll show you the Part B. So for the Part A, set up as this. So if Joe is first because it's in alphabetical order. So if Quinn goes, then we get an alarm. And then if Nate tries to go first, we also get an alarm. And then if Joe goes, then we go to our first state, S1, I guess you could call it. And then if Quinn tries to go, then we get another alarm because it's out of order. Then if Nate goes, then we get the next state. And then if Nate tries to go again, it doesn't do anything. Or if Joe somehow triggered again, it doesn't do anything. And then if Quinn goes, it triggers and then we get our output. And then if any one of these were to trigger for some reason, it no longer, it still keeps the output there. Unless, so if we have two somehow triggered, then we get an error. And we'll get a error correcting. And it should go to the proper state then. But based on how the circuit's built outside of this, that is impossible. Let me pause this real quick. Okay, so here's our overall circuit for this Part A, and I can show you it working. This is a shift register here. It has 5 values just because then when it's holding a value, it's not trying to pass stuff on here. And then that's also why this counter is set to count up to 5, because what it's set up to do is run 5 clock pulses. After that 5th clock pulse, then it stops, and then it'll reset every single one of these so that we don't end up with an error like this one gets stuck in a state, or any of them get stuck in between states if, say, it triggers too quickly or something else. And then this is just making sure, hey, this is saying, hey, I got an output, so then start counting this clock. So if Queen tries to go, it holds it there until I release it. It should be momentary. And then let me slow down the clock so you can actually see it a little better. Okay, I fixed the issue. It ended up being that this clock thing got messed up when I was doing the first example. I fixed it now, so let's go back through Joe again. We'll show Joe triggers, he's good. Then we'll go Quinn, see what happens when Quinn does it. Alarm, nothing. And then when Nate goes, it's good. That label's a little wrong there, but I'll fix that then. And then if Quinn goes, it's good. Everyone's present. We get this D flip-flop toggled, and then we're good. I'm going to pause it again. Okay, so now we're over here at Part B. We have our circuit that I just described here, this whole thing, with a clock and everything all together. And then, like I said earlier, these were added for this Part B specifically so I could put constants in here, which are the numbers that we would input to trigger our first combinational circuits. And then these are run into controlled buffers so that they only output if we are in the right order. And then we get we got Joe's, it's real simple circuits, but you'll have already seen those pretty much. Though there was a little bit of redesign because of issues and stuff, but they're all fixed now, just to make sure that everything works together. And then this all will trigger this here. Let me pause real quick. I think I gotta fix one thing. It's enabled real quick, but it doesn't much matter because I can slow the clock speed down a little bit, I guess. Let's bring it down to like 32. So we'll go, let's try Quinn first. Quinn doesn't do anything. Then we try Nate, doesn't do anything because it's wrong order. Then we have Joe. Joe goes in, then Joe punches his number in, correct order. Then we try Quinn again, doesn't work because it's out of order. And then we have Nate go in, Nate punches his number in, we're good. And then finally we'll have Quinn go in, and then Quinn punches his number in, everyone's here, all numbers entered correct. They're ended together, which then triggers this key flip-flop, and all personnel is present, and the work can begin to restart that reactor.
For our circuit, we have our input, and then this is our pulsing, and then our light turns on every clock cycle, will stay on. And then if you pulse this again, auto correction occurs, and then once you flip the 3 inputs, this shows on that is good, and this shows that both are working. Now if this happens, then the next clock cycle, it'll redo itself and be continuously working on every clock cycle, even with a pulse into the flip-flop. The next clock cycle will fix that.